Hello, today I'll be talking about project number 12 on Tinkercad. It's the knock block project. The overall goal of the project is to create a device that will use a piezo buzzer as an input sensor to detect vibrations and then lock or unlock a lockbox if a person knocks the proper way, the proper number of times. In this case, it'll be 3 times. The components involved are a push button. The second push button will be used later to replace the piezo to test the code. Since the piezo, you can't actually use it as an input sensor on Tinkercad. We have the electrolytic capacitor here to reduce noise on the ground and power rails. We have the servo motor, which rotates here at 360 degrees, has separate power and ground lines than its data line. We have 3 LEDs, separate colors, each connected to a digital pin through a 220 ohm resistor. We have a 1 mega ohm resistor here connected to the piezo buzzer, connecting the piezo buzzer to ground, and we have a 10 kilo ohm resistor connecting the push button to ground. We have an Arduino R3, and of course all of these are all connected together on a breadboard. That's all for components and how they work. Onto the code. We first start by including the servo library and then creating a servo object, and then we declare our global variables we have 5 here defining the pins that each of our components are connected to. Later we'll define the pin that the servo motor is connected to. We have the knock and switch val, which we are just defining here, and we'll assign values later. Knock val is used to determine or used to compare with the loud and quiet knock global variables to see whether the knock is valid. Number of knocks is our counter for the number of valid knocks that the person has done, and switch val is our variable that we'll use to assign the value coming off of the push button. Here we have quiet knock and loud knock, which are constant variables to compare to later, and we have our Boolean variable here locked, which starts at false, which means our device is going to start in the unlocked position. And we will alternate this between true or false to change whether or not the box is locked. Here we are defining a Boolean function that we will use later in our code called check for knock that takes an integer input value. Begins by the whole thing is an if-else conditional. The if conditional compares the input value to quiet knock and loud knock, and if the input value is in between quiet knock and loud knock, we flash the yellow LED for 50 milliseconds, turn it off, and then let the user know, or let the person know through the serial monitor that the knock was of a valid value, and then return true from our function. If we have any other value for our knock, then we'll tell the person that it's a bad knock and return false. Here in our setup function, we are assigning pin 9 to our servo motor, to our servo object. Our servo motor is because our servo motor is connected to pin 9. We are switching the LED pins to output pins so we can turn them on and off, and then our push button pin to an input pin so we can read whether it's being pressed or not. For serial begin, we are initializing a serial transmission over the serial port on the Arduino at 9600 bits per second, so we can display things on the serial monitor. And here we are writing, using digital write to write a value of high to our green LED's pin so we can turn it on and have our device start with the LED turned on, the green LED turned on. And then for this next line of code, my servo write 0, we are initializing the servo motor at 0 degrees, which will be the unlocked position. So it will also begin with that unlocked, and we will print to the serial monitor that the box is unlocked. And then onto our loop, we have two different blocks here. One for when the box is locked or when the box is unlocked, and then one for when the box is locked. For when the box is unlocked, we will assign the digital read of the push button to our switch valve variable, and then use an if conditional to see whether a person is pressing the push button. If they are pressing the push button, then we will lock the box by switching the Boolean variable lock to true. We will turn off the green LED, turn on the red LED, and move the servo motor 90 degrees to the locked position, and print to the serial monitor that the box is locked, and delay 1 second or 1,000 milliseconds so that the servo motor has time to change positions before we get any other user input. And then on to the conditional for when the box is locked, we will assign our knock value variable to the value read off of the piezo buzzer, and then we will run a nested if conditional. For the outer if, we will be comparing the number of knocks to see whether it's less than 3, and if the knock val is greater than 0, i.e. the piezo is getting an input. If both of those are true, then we will check this. We will run our knock val variable through our check for knock function to determine whether the value of the knock is valid. If it is valid, then we will increment the number of knocks. At the end of this block, we print to the screen 3, which is the number of needed knocks, minus number of knocks, which starts at 0. And to tell the user how many more knocks they need to unlock the box. This will run as long as we are getting input and number of knocks is less than 3. So essentially, this will always run while the number of knocks is less than 3. And then once the number of knocks equals 3, we will run the last conditional, where we will set the locked variable to false, write to the servo motor to change back to 0 degrees, which is the unlocked position, and delay 20 milliseconds before changing the LED states, and then turn the green LED back on while turning the yellow LED off. The user will be notified in the function whether their knock was valid or not, so we don't need to print that later. And yeah, that's the whole project. So I will, with the piezo buzzer on, so I will switch out the piezo buzzer for a push button so that we can actually run the code and see how it goes. Alright, So we start the simulation here. You can see, let me zoom out. So when we start the simulation, you can see the servo motor move to the unlocked position. The green LED is on, signifying that the box is unlocked, and the box is unlocked is printed to the serial monitor. And then when we press the push button that locks the box, the green LED turns off, servo motor rotates to the locked position, and the red LED turns on, and the person is notified that the box is now locked in the serial monitor. Actually, you also have to change this constant variable for, oh, it was already changed, for loud knock, so that it corresponds to a value coming off of the push button. If we were using the piezo buzzer, we would use this value of 100 rather than 1024, but the push button gives an output value when pressed of 1023, and we need a value greater than that to actually unlock the box with our code. And so now that the box is locked, when you press the button once, it's always going to be successful with the push button. The yellow LED lit, and we see that we only need 2 more knocks. Yellow LED lit, 1 more knock, and the last time, the servo changes position back to its unlocked state. Green LED turns on, and we see that the box is now unlocked, and we can lock it again and go through the whole code again. And now that is it for the project. Thank you.